So in this section, we're going to go ahead and go over solving exponentials with logarithms. Earlier in the chapter, you learned how to solve them without in problems like this. Okay, to solve an exponential with no logarithm, you would just do the changing of bases. So I would change both of these to a base of 2. 16 can be written as 2 to the 4th power, and because their bases are the same, their powers have to be the same. So that is an easy way to solve it if you're able to change the bases of both sides. Now, for every problem that is not possible, for example, one like this, I cannot change 25 to a base of 2 in order to get their powers to match. So when that happens, you have to use the inverse of an exponential to get at this x that's up in the power, and you do that by using a logarithm. Exponentials and logarithms are inverses of each other, so they will help cancel each other out. Let's take a look at a couple examples, starting with this first one. So this is example 15 from the book. Let's make it a little bit bigger if we can. All right, so this first question, we have 2 to the x equals 10, and that one is not one that is possible to solve with changing the base. So we have to resort to using a logarithm. So the main thing here is you want to be able to use your log rule that says you can bring the power to the front. Okay, and that's going to help drop the x down in order to make it solvable. But before you are able to do that, you have to have the log in front. That's the only way that you're able to use that log rule that says you can bring the power to the front. So if I add the log to the left side, I also have to add the log to the right side. So I can sneak it in here. Okay. So what this does is it brings the power down. And then all you have to do is divide. And now you'll have x by itself. So I'm going to type into the calculator log 10 divided by log 2. Make sure when you do your logs, you close the parentheses. So the calculator will put it like that. You need to close it on both. Log 2. So we'll go with 3.322. So let's do the next one, part B. Same thing. I see a power that has a variable in it. I cannot change 3 and 20 to be the same base. So in order to solve this one, I need a log in front. And what I do to one side, I always have to do the other side. Keep in mind, these are both log base 10. We don't write them. Our calculator is already in base 10. So our power is going to jump to the front because that is one of our log rules that says that we can do that. So I have 2x times log 3 equals log 20. And now I can divide. So now the 2 is gone, the log 3 is gone, I'm left with just x, and let's go ahead and plug that one in. So log 20 divided by 2 log 3, 1.363. In part C, this one's a little bit more complicated. If you can see what's in the power, it's an expression. And when it's an expression, it takes a little bit longer to do. So we're just going to have to take it piece by piece. So same thing, I want what's in this power to come down and not be in the exponential anymore. So in order to do that, I got to do the log. like so. Okay, my whole power comes down, because that is one of my log rules. Always use parentheses if it's an expression. Okay, I can divide by log 5. Always keep your answers as exact as they can be to the very end, as long as you're okay with plugging it into the calculator. Okay, I just have 2 more steps. I need to subtract the 1, so that's gone, and then divide by -2. Okay, so this might be a little bit tricky to plug into the calculator, so I would recommend putting parentheses around this whole piece. Obviously, you'll have some parentheses around the logs that it will automatically give you, and even maybe throw an extra set of parentheses around the top. If you're on your phone, that's super important, but if you're in Desmos or graphing calculator, sometimes they'll split it up for you really nicely. So let's go ahead and calculate this. Log 50 divided by log 5 minus 1 divided by -2 is -0.715. And there we go. There's a couple examples of how to use logs to solve an exponential function. The main thing you want to think about here is putting a log on both sides of your equation and then bringing the power down to the front.